Hello everyone, I'm Amit. In this lecture, we will try to solve some problems of the chapter gravitation. So, to start the video, I'm sure you have gone through this chapter. Okay. So first, read all the chapters and make a formula sheet. After that, you should come back and we will continue with this video. Okay, fine. So, welcome all of you once again. So, actually, we are going to solve chapters from the problem from the chapter Gravitation Class 11 NCERT. Okay. So let's start. Actually, we will not solve each and every problem. We will try to solve some of the problems. Since if we will go through all the problems, it will be a long video. So let's make it short. So the first question, answer the following. The question is, you can shield a charge from electrical force by putting it inside a hollow conductor. Can you shield a body from gravitational influence of nearby matter by putting it inside a hollow sphere or by some other? Okay. So, first think about the answer and then come back and please try to think yourself. Okay. So the answer of this is written here. Gravitational influence of matter on nearby objects cannot be explained by any means. This is because gravitational force, unlike electrical force, is independent of the nature of the medium. So this will be the answer. See, one thing, electrical force basically depends on the nature of the material. Nature of the material, I think you haven't read the chapter electrostatic for the class 12. So we will just let me explain. Actually, what happens that the electrical force between two charged objects is directly proportional to the magnitude of charge, the product of magnitude of charge, and inversely proportional to the square distance between them. So, in a similar way, like gravitation, there is a constant known as k, which is equal to 1 by 4 pi epsilon, where epsilon depends on the nature of the medium. Okay? Epsilon basically depends on the nature of the medium. Unlike that, gravitational force does not depend on the nature of the medium. Simply gravitational force does not depend on nature of the medium, so you cannot put any object to shield it from gravitational influence. Okay, let's proceed. The second question is, an astronaut inside a small spaceship orbiting around the Earth cannot detect gravity. If the space station orbiting around the Earth has a large size, can he hope to detect gravity? Means, if the space station is large and it is orbiting around the Earth, then can we hope to detect gravity? So the answer is yes. Yes. If the size of the space station is large enough, then the astronaut will detect the change in Earth's gravity. Then it will detect the change in Earth's gravity. Another question, if you compare the gravitational force on Earth due to the Sun with the Moon, you will find that the Sun's pull is greater than Moon's pull. However, the tidal effect due to Moon is greater than that of Earth. Why? If you compare the gravitational force on the Moon due to Sun with the Moon, you will find that the Sun's pull is greater than the Moon's pull. However, the tidal effect due to Moon is greater than that of Earth. Basically, the tidal effect on Earth is due to Moon. Remember this. And the tidal effect on the Sun, on the Earth due to Moon is greater. That is always greater. The reason behind this is that the tidal effect depends inversely upon the cube of the distance. Remember one thing, tidal effect depends inversely upon the cube of the distance, while gravitational force depends inversely on the square of the distance. So, since the distance between Moon and Earth is very small, than that of Earth to Sun. Earth through Sun distance is very large as compared to the distance from Earth to Moon, and the tidal force depend inversely 1 over r square, inversely 1 over r cube, inversely 1 over r cube. So the tidal effect due to Moon is greater. Okay. To the next question. What is the question? The question is: suppose there existed a planet that went around the Earth twice as fast as Earth. What would be its orbital size as compared to that of the Earth? Means, if suppose there is a planet, suppose there is a planet and its time period to revolve around the Sun is half as that of Earth, then what would be its orbital size? Orbital size means basically, if there is Sun, let us consider this is Sun, then this is basically the orbital size, means the path that it traverses around the Sun, that will be its orbital path. Okay. So remember one formula. So we know that let the time taken by the Earth is Te. Okay. The time taken by the Earth is T and that of the planet is Tp. So the relation between Te and Tp will be what? It is written that the speed is double, means the time it will take is half. So Tp equals half of T, means Tp upon T, that is equal to half. And we know that from Kepler's law. This is very important law. There are three laws of Kepler. One of that is R cube is directly proportional to T square. Means orbital size, cube of orbital size, means basically cube of orbital radius, is directly proportional to the square of time it will take to complete one complete revolution around the Earth, around the Sun. Around the Sun. So R cube is directly proportional to T square. So RP upon RE from this formula is equal to T square over T square. Directly from this equation. See this equation. R cube is directly proportional to T square. So RP upon RE whole cube, that is equal to TP over TE whole square. There is such dependence. So RP over RE, if 3 goes this side, it will become 2 by 3. So RP over RE and TP over T is half. TP over T is half. So RP over RE equals half to the power 2 by 3. Since 3 goes there, so RP equals 0.63 RE. So the answer will be lesser by a factor of 0.63. Lesser by a factor of 0.6 means RP is basically 0.63 times RE. Okay. So proceed. The next question. Which of the following symptoms is likely to afflict an astronaut in space? Solving phase, headache, orientation problem. So everything is written. I don't have to recite this. So I'm holding it for 30 or 40 seconds. You just read it, and after that you will proceed. Fine. So just read it. Means, what are the things that can affect an astronaut in space? Is that swelling face, headache, orientation problem? So basically the answer is B, C and D. B means swelling face, obviously. C, headache, and D is orientation. Just read this part. Okay. Okay, can you proceed? Yeah. So please read this part. Okay. This is an important question. See what happens. A rocket is fired from the Earth towards the Sun. Okay. At what distance from the Earth's center is the gravitational force on the rocket is zero? At what distance from the? At what distance at what distance from the Earth center is the gravitational force on the rocket is 0. So, one sec please. So, let us consider this is the Earth and a rocket is fired towards the Sun. And what we have given? What there is given that we have to find the point at which the gravitational force is 0. How the gravitational force will become 0? Since this earth will pull this rocket towards its side, and sun will also pull the rocket towards this side. So at a point, there comes a point where the force due to earth will become equal to that due to sun. So let the distance from the center of the earth, let that point be P, and its distance from the center of the earth is x. So if the whole distance, if this distance is r and this distance is x, then this distance will be r minus x, and we have given the value of r. So let's start. Mass of the sun, that is ms, equals 2 into 10 to the power 30 kg. Fine. Mass of earth equals 6 into 10 to the power 24 kg. All these data are given, and r is the distance from the sun to the earth, the center to center distance, that is basically 1.6 into 10 to the power 11 meter. So let us consider that the mass of the rocket is m. If m is the mass of the rocket, then if x is the distance from the earth center, then the gravitational force, what will be the formula for gravitational force between the sun and the rocket, is g, mass of the rocket, mass of sun divided by r minus x whole square, and that will be equal to g, mass of the rocket, mass of the earth divided by x square. So after solving some algebraic thing, basically g will be cancelled out, n will be cancelled out. So r minus x whole square upon x square, that will be equal to ms over ne. Ms over ne means mass of sun over mass of earth. So r minus x upon x, that will be equal to under root of all this. And we are given the value of ms and ne. So ms is 2 into 10 to the power 30 and ne is 6 into 10 to the power 24. So the root of this is basically, after solving a simple algebraic part, we will get x, the value of x is equal to 2.59 into 10 to the power 8 meter. Fine.